So in this video, I'm going to discuss the distinct values problem which occurred in today's CODECHEF challenge. It is given that you're given, this is the number of test cases, this is the n, value of n, and this is the array of size n. And what you have to do basically is you have to check all the possible subarrays of length greater than equal to 2 such that the difference between the maximum and the second maximum you have to find, and you have to find how many such unique values are there. Okay, so for here, like say 1 1, there is only one sub array, so the maximum is 1 and the second maximum is also 1, so 1 minus 1 is 0, right? So there is only a unique value. For this 4 2, maximum is 4, second maximum is 2. This 2 1, maximum is 2, second maximum is 1. So for 4 2, it is the maximum minus minimum is 2. For 2 1, it is 1. And for 4 2 1, that is the whole subarray, the maximum is 4 and the minimum is, the second maximum is 2, right? So it is also 2. So number of unique is 2 and 1, because 2 is repeated, so the number of unique is 2 and 1. Similarly for this case, you will find that there are four such unique values, and this case also 4 unique values. Now the basic code, what we are going to do is, this is a very important code where, like, our goal is to target a position and check out the next value of the next value towards the left and the next value towards the right, which is greater than that number. Okay, which is greater than that number, the next value. So like for this case, so for 4, there is nothing greater than, nothing towards the left, so we check for right side which is greater than 4. Is there anything greater than 4? Nope, there is nothing greater than 4, so we are going to ignore it. For 2, is there anything greater than 2? Yeah, 4 is greater than 2. For 2 over here, nothing greater, so 4 minus 2 is 2. Okay, for 1, what is the next number which is greater than this? 2. Towards the right, nothing, so 2 minus 1 is 1. So these are the values. Okay, for this 8, towards the left nothing is greater, towards the right nothing is greater. For 1, towards the left 8 is greater, so 8 minus 1 is 7. And for 1, towards the right 7 is greater, right? So 7 minus 1 is 6. For 7, towards the left 8 is greater, and towards the right nothing is greater. So towards the left 8 minus 7, that is 1. For 2, towards the right nothing is there, towards the left, just left 7 is greater, so 7 minus 2 is 5. Okay, so how many values are there? 7 6 1 5. So there are 4 values, that's 4. Okay, so this is the concept that we are going to use. So what we are going to do, first make a array left grade. Okay, left grade n. Okay, let's just name it left, and one is right. Okay, there are 2 arrays of size n, which is going to store just the left element. This is going to store just the left element which is greater than that number, and this is going to store just the right element which is greater than that number. So what we are going to do, we know the prefix sum, that concept. So left of 0 will be minus 1, because nothing for the leftmost element, there is nothing towards the left of this, and right of n minus 1 will also be minus 1, because towards the right of the rightmost element there is nothing greater than that. So this is one thing. And now we are going to use the concept of stack. Okay, the concept of stack. So let's say we have a stack called BRR. Okay, let's like, if you know the stack, okay, the stack concept. So there is a stack called BRR, and you are going to run a loop from I is equals to 1 to I less than n, I plus plus, and while the top of the stack, that is while the stack is not empty, and the top of the stack is lesser than ARR of I, we are going to decrease top, okay, by 1 every time. That is, we are going to find the leftmost element which is just greater than this. And once we have done it, now there is a condition. If stack is empty now, okay, like if we have, okay, not top minus 1, it would be pop, okay, stack dot pop. So now if the stack is empty now, we can say that L of I, the left of I, is equals to -1. And if it's not empty, then left of I is the topmost element, okay, stack dot top. Once we are done with this, now we are going to push ARR of I to it, okay. This is the code for the left. For the right, the code will be I is equals to n minus 1. Actually, not from n minus 1, because n minus 1 we have defined. So from n minus 2, I is greater than equal to 0. I minus minus. Run a loop. Same thing while top is greater than equal to while, like, this was a Java code. Like, if you don't know the uses of stack, then you can use this, but try to use that stack thing. So while stack is not empty, okay, that is empty of stack, not that thing, okay, just use the condition and stack dot top is lesser than ARR of I, okay. So we are going to do pop, and if stack is empty, after this while, if stack is empty, then we will say that, sorry, not left, right of I is equals to -1, because there is nothing towards the right which is just greater than that. Or if there is something, then right of I is equals to top of stack, okay, top, stack dot top. And after done with this, what we are going to do, we are going to push ARR to the stack, okay. So once we are done with this, now you can use a map, okay, a map or anything else. Like, if you're a Python coder, you can use something else. If you're the vectors things, okay, it will be preferable to use the map. And run a loop from I is equals to 0 to I less than n, I plus plus. And in this, if left of I not equals to -1, then we are going to add, okay, if it's not equal to -1, so there will be a difference which will be, like L of I, okay, that is left of I minus ARR of I, okay. This is the difference, that is the just the element just greater than ARR towards the left and ARR, because this is the second maximum, this is the maximum in that range, okay. So this difference, and you have to check if map does not contain difference, then answer plus plus, and after that map dot put difference, okay, like put the difference in it. You give anything, any value over here, okay, like if you want you can give 0 also, or 1, 10 also, okay. That is just assigning just a number to this key, okay. So we are putting this in the map, and if it's not there, then answer plus plus, because that is a unique one, so we are going to count it. And if right of I not equals to -1, then difference is equals to right of I minus ARR of I. And again, if map doesn't contain difference, then it is unique, and make increment answer, and don't forget to put that difference, that whether unique or not, just put it inside the map, okay. And this is the key, and you can give any value like 10. Okay, for here I'm giving 10, you can give any other value. So once done with this, uh, close the bracket and print answer. Okay, so if you want, I can run this thing with 69421. Okay, we will be running it very quickly. 69421. So for the left array, this is -1, and this, okay, we are going to use a stack. So this is -1 and we insert 6 to it. 9, is 6 greater than 9? Nope. So we cancel it out. Now the stack is empty, so this will be -1 again, and we are going to insert 9 to this. Is 4 greater than sorry, is 9 greater than 4? Yeah, it's greater than 4, so this is going to be given as 9. Okay, and we are going to add 4 to this. For 2, is 4 greater than 2? Yeah, it's greater than 2, so we are going to add 4 to this, and we are going to push 2 to this. For 1, is 2 greater than 1? Yeah, it's greater than 1, so we are going to add 1 to this and make this 2. And for right, this is -1, and let's say this is the stack, so this is -1 and we are going to insert 1 to it. Now check if 2 greater than 1. Yeah, 2 is greater than 1, so we have to pop it. Okay, and push 2 to this, and since we are popping it, so since the stack was empty, so it's -1. For 4 is greater than 2, so we are going to pop it, and this is -1, and then push 4 to this. Okay, 9 is also greater than 4, so we are going to pop it -1 and push 9 to it. 6 is lesser than 9, so we are going to make 6 over here, and since 9 was at the top at that moment, so this is 9. Now check for every element. Okay, for 6, 9 minus 6 is 3. For 9, both are -1, so we don't need to check. For 4, 9 minus 4 is 5. For 2, 4 minus 2 is 2. For 1, 2 minus 1 is 1. So how many are there? 1, 2, 3, 5. So these are the values. Okay, and these all are unique. So you can say that the answer is 4. That's it. Thank you.